Number 23 is our first ICE problem. We have an equilibrium system shown up here. This whole thing is our equilibrium system. Right? We see it's 2 molecules of NO plus 2 of hydrogen gas are in equilibrium with 1 nitrogen gas molecule and 2 water gas molecules. And we're given all of this information at the beginning, that we have the initial concentrations, and they didn't tell us anything about N2. That's why I was able to say, oh, that's going to be 0, because they didn't tell me anything about it. And we're given the concentration of NO at the end of the reaction when it reaches equilibrium. So the question is, what happens in between? From the equation, I can tell that we've got minus 2x, that this side, the reactant side, has to disappear, because the only thing this can do to get to equilibrium is to create nitrogen gas, because it was starting out at 0. So the easiest way to get the ratios correct in the change line is to use the coefficients from the equations. So this one has to disappear by 2x. Hydrogen also has to disappear by 2x. Nitrogen is going to appear by 1x, and water is going to appear by 2x. Now, since I have a number down here in the equilibrium column, then that means I can not use x, I can calculate it. What is the difference here? It's minus 0.038. And since this is 2x, that means this one is also 2x, so it's also minus 0.038. This one for the water was plus 2x, so it'll be plus 0.038. And the nitrogen gas, that was just x, so I use 1/2. Plus 1/2 of 0.038 is 0.019. So now it's as easy to just do this little math problem and find my equilibrium concentrations. So that's the first piece. Once you know your equilibrium concentrations, you can now come up with the equilibrium expression, products over reactants, and substitute in the numbers that you have found and evaluate it. 650. Right? Remember, Kc has no units.